Okay, we're starting a new chapter. Write down your homework in case I haven't posted the syllabus. It's right there. If I have posted the syllabus, it'll be on there. What is a conic? So a conic is when you take a cone. Do you see this kind of picture of a cone right here? It's kind of, almost like an upside down ice cream cone kind of thing. So we're talking about conics this whole chapter. That's the official name. And so I want to just show you what it is. If you take two cones and kind of stack them on top of each other, if you can imagine that flat on a table, um, if you cut completely level with the table or the ground, it will form the intersection of the cut. That region there will be a perfect circle because a cone is circular. The bottom and top of this of these cones in this case are circular. So if you cut it completely level, it forms a circle. That's a type of conic. If you cut it just at a little bit of an angle, it'll be kind of a squished circle, or you might think of that as an oval, but we call it an ellipse in math. But you've probably seen an oval before. It does look kind of like a squished circle. Third type you could create if you actually cut outside of the bottom there, instead of forming a full kind of ellipse there, it forms actually the intersection there of the plane and that cone there forms a parabola. So that's actually one of the type of conics we're going to talk about today, actually. There's one last one that's called a hyperbola. It almost looks like two parabolas kind of going in different directions. When you cut this thing completely vertical at a straight 90-degree angle there. But actually, that's not really a parabola. It's not really a parabola. The two of them together make a hyperbola. It has a little different shape, quite a bit different shape actually than the parabolas do. So they go up, they kind of increase at a different rate. So I'm going to show you the definition. Well, first, let's talk about this. So one of the things we're going to do, we're kind of baby stepping. So in all of our examples today, the origin will be the vertex of the parabola. So some of them might look like that. Some might look like this, kind of like a sideways parabola. But the vertex will be at the origin. So kind of take it easy. Later we will step it up a notch and the formulas will change. By the way, as far as formulas go, make a really good formula sheet because this chapter, the test, I will allow you to use a formula sheet. I'm not going to make you memorize all the formulas. So when I get to formulas, make sure you take good notes because you want to use those on the quizzes and tests because I'm not going to make you memorize the formulas. This is the official definition of a parabola. You've probably never read it before. A parabola is a set of points in the plane that are equidistant from a fixed point F. We call that the focus, so the point is F. Then a line called the directrix. So that's a line and a point. So a parabola somehow has to do with this focus point and a line called the directrix. So to visualize that, I'm going to show you just a calculator program here. So any point on this parabola, no matter where I move point P, it's on the parabola. It kind of stays on there. If I measure the distance from point P to the F focus point, it is PF is 3.98. If I measure the distance from a point to a line, by the way, the quickest way to get there is at 90 degrees. You may notice that this line is drawn at a 90-degree angle, and that's also 3.98. And it doesn't really matter where I put the point. It's always equidistant to the focus and the directrix line. That dotted line down there is the directrix line. And here it's 5.44 to there, 5.44. It's exactly the same distance. The easiest way to see that is when you get to, like if you put this point on the vertex, which is actually pretty helpful here, that distance from the focus to the vertex is in this case 0.751, is also equal to the distance from the vertex to the directrix there. So that's why that definition maybe starts making sense here. So I do want you to take really good notes on the formulas here. So I'm going to kind of draw a picture of it so you can see it, and also just kind of talk through a few things. And I haven't finished all the formulas, but we will in a minute. So again, for all these formulas, you might want to specify in your notes that these are when the vertex is at 0, 0. So these formulas are only good when the vertex is at 0, 0. And it is for every one in this section anyway. And so instead of h and k here, I'm going to put 0 and 0 because h and k are 0 and 0 for this problem. So our formula actually is a little simpler than this. I don't need that whole formula. It'd be y equals a x squared. So I would use that formula for this section. When we get to the more complicated section, we'll bring this one back because hk is not always at the vertex, but for this section, it is. So I like to label things. So that's actually a pretty helpful thing to do here. So we're going to say this is the focus point here. And I guess this line right here is the directrix. And the distance from the focus to the vertex is always a distance of c. Sometimes c is negative, but as far as distance goes, distance is always positive. So even if c was negative, the distance there is c, or absolute value of c. The distance from the vertex to the directrix is also c. Remember, those are equidistant, right? So those distances are the same. Those are c. So the formula for the focus point is going to be 0, c. Again, this formula is only good when the vertex is at the origin at 0, 0. The equation of this line right here, the directrix line, is going to be y equals, because it's horizontal, and the opposite of c, because if c is, say, positive 2, it looks like it's positive 2 here, then the opposite of c would be the opposite of 2, or y equals negative 2. There's one last thing that's on here that you do need to know. It's called the focal diameter. So the focal diameter formula is focal diameter is equal to the absolute value of 4c. So the distance from this point to this point, that focal diameter is that dotted line there, that dotted pink line. It is parallel to the directrix, and the distance, the complete distance from here to here, is 4c, or in this case, is 4c, or like 4 times 2, or 8, if you just look at the graph there. But the thing I want you to see is when you're drawing this, it's almost more helpful to think of this as half of that as 2c, and this is half of that as 2c. I mean, I guess I could be putting absolute values around these because these are distances, they're positive. But it's going to be really helpful to start at the focus, go, if it's this kind of parabola, you're going to go 2c to the right and 2c to the left, which is a total of 4c. That whole thing there is the focal diameter. So that's what you need for that. Okay, so this one, we're going to find the focus and directrix of this parabola. So this is a parabola. If you look at this formula, you notice that y is to the first power, and it's solved for y, and x is to the second power. So when you see that one of these variables is to the first power, always solve for that variable. It may not be obvious in some problems, but because y is to the first power, I definitely want you to solve for y. So we're going to divide by -8 here. And you get y equals, I'm going to write that differently so you can see the a value a little more clear. So -1/8 times x squared. So that's really a coefficient of a fraction right there. So that's our equation, right? If you look back at this, the a value is the number in front of x squared. So we can easily see what number's in front of x squared. A is equal to -1/8. I forgot to mention one formula on here. It's actually really helpful. We'll use this. If you know C, you can use it to find A. And I'll add one more to this. It's another version of the same formula. It is C equals 1 over 4A. By the way, I want you to know the 4C and the 4A there are in the denominator. It's not 1/4 times A or 1/4 times C. It's 1 over 4C, 1 over 4A. Okay, so if we know A, we can figure out C. So let's use the formula we just mentioned. So C equals 1 over 4A, and A is -1/8. So this is 1 over -4/8, which is -1/2, Divided by a fraction is like multiplying by its reciprocal. So we're going to multiply by -2 or 1, and we get -2. So my C value is -2. So that's very helpful here. So I'm going to try to draw this. This may sound weird to you. Try to draw it without using a lot of formulas. And then I'll show you how to kind of fall back and use the formulas if you need them. They're kind of there for a crutch and you can use them, but don't, sometimes you can just kind of think it through a little bit here. So we've got C equals -2. So when you see this, like the y equals x squared graph really well, right? That looks, kind of like that on the axis. When you have a negative number here, or negative value for C, either one really, because they'll always be the same. A and C will be the same sign. It's definitely going to, instead of opening up, it's going to open down when this is a y equals parabola, which it is. So right away, I kind of know, sometimes it helps to know this parabola is opening down, which means the focus must be inside of that parabola. That focus point is inside. So let's start with what we know. We know the vertex is there. We know from this that the distance from the focus to the center is C. Because this is a negative value here, because A is negative and C is negative, instead of opening up, it's going to open down. So I know I'm going to go down 2 units because C is -2 here. So I'm going to go down 2 units. That's going to be my focus point. If I go up 2 units the other way, that should be my directrix, which is y equals 2. Now for this, it really helps to, let's just check the formulas and make sure that we did everything right. So, and this is sometimes what you can do. You say, okay, the formula is 0, C. So we know C is -2. So this should be the point 0, C, which is -2. Is that the point 0, -2? It is. The directrix equation is y equals the opposite of C. So y equals the opposite of -2 is 2. So y equals 2. That works. So I've got those two things. I did those two things correctly, which is very helpful. I think the hardest thing to do is probably that focal diameter. So I'm going to put a couple more tick marks here. So the whole focal diameter would be, let's see, focal diameter would be absolute value of 4 times C, which is -2. Oops. So we get absolute value of -8, which is 8. So I need to go 4 in each direction. So I go 4 to the right and 4 to the left, make my points. Those are my dotted lines, right? That's a dotted line that connects those two. Try to make that dotted. And you're going to be able to now draw the parabola. So if you have the vertex point, you have the end point of the focal diameter, you have the other end point. Those are all the points I need to solve and graph this thing. So you doesn't have to be a perfect graph, just those 3 points, the end points of the focal diameter and the vertex are the points I want when you use this method to graph or solve. Okay, get your formula sheet out again. This time we're going to go over the formulas for a sideways kind of parabola here. So the vertex is still at 0, 0, so that's our vertex. And so that means this is 0 and this is 0, which means our equation really is much simpler. It's x equals a y squared, or a times y squared. Let's figure out what C is by looking at the graph. So you can kind of find C from the graph. So it looks like it's 2 units, right? That distance of C equals 2 there. It's opening to the right, which is a positive direction. Up is also a positive direction. So I do think it's a positive 2. We'll double check that in just a minute if you're not sure. And so if I go 2 units in the other direction, that's going to be x equals -2. So without looking at the formula sheet, I think those two are right, but let's just look back at the formula sheet. Oh, this is the formula sheet, isn't it? Sorry. Sorry, I was looking at this like it was a real problem. So let's actually just label the stuff that we need. So we need this equation, sorry. It has all the points in there, just starting to go to town. So the formula, if you look back at the formula for this one, it was 0, C. Well, this one's kind of similar, except it's facing the other way. So instead of 0, C, it's going to be C, 0. The directrix was, for the other kind of parabola, y equals the opposite of C. But this one's a vertical directrix, so it's going to be x equals the opposite of c. And again, the focal diameter is the same. It is equal to the absolute value of 4c. Okay, and so again, this distance here, I prefer to think of it as this is 2c, or absolute value 2c, and this is the absolute value 2c. Those two together make up the focal diameter of 4c, or the absolute value of 4c. This one's a little tougher to solve. You got like, what do I solve for? X is to the first power, so I highly recommend solving for x there. So I would probably add 1/2 x to get rid of the denominator and help maybe solve for that. So plus 1/2 x. And those go away. You get y squared equals 1/2 x. What do you do to both sides to solve that guy? Hopefully you know you'd multiply both sides by 2. Multiply by 2. And this nicely cancels. You get x equals 2y squared. Now this point a would equal this, right? That's a, which is 2. And there's a formula to convert it to get c. So c equals 1 over 4a. We're using a lot of formulas. We really need to get c to do some graphing. So this would be c equals 1 over 4 times 2. So c equals 1/8. It's going to be a really tough one to graph accurately, because c is just a very small number here. So because c is so small, I'm going to do it this way. So I'm going to make this like 1 unit, 1 unit, 1 unit, 1 unit. So that's going to be 1, 1, that's -1, that's -1. I'm going to make this like a 1/2 a unit. So that's a 1/2 a unit. Those are all 1/2, 1/2, and -1/2. I'm going to make this one a 1/4 of a unit. So 1/2 of a 1/2 is a 1/4, so that's 1/4. And 1/8 is somewhere, I guess you would say, let's see, which way is this opening, right? So c is a positive number. So I'm thinking it's either opening up or to the right. Those are positive directions. But this is definitely an x equals graph. So right away, this is opening not up or down. This has to be right or left in this case, because c is positive, it's going to open to the right. So I know if the distance away from the vertex to the focus is a distance of 1/8. So actually this point right here would be my focus point, which means this vertical axis of symmetry is going to be x equals -1/8. And we haven't quite finished graphing. I think that one, we didn't. Okay, so you've got to go how much in each direction. So let's think about that. So if the focal diameter is 4 times, absolute value of 4 times c, it would be 4 times 1/8, or 4/8, which is 1/2. So 1/2 is your entire focal diameter. So I don't need to really go up 1/2 and down 1/2. I need to go half of that distance. So half of 1/2 is 1/4. Half of -1/2 is -1/4. Now I have enough points to graph my graph, because I have my endpoints and my vertex, and I can go ahead and graph the graph. I think you're getting this. You just want to make sure. So this would have to be classified as like a y equals ax squared kind of equation, like it opens up or down. I know that a must be positive because this graph opens up, or positive, in a positive direction. This graph right here would be an x equals ay squared kind of graph. And a would have to be negative because it's opening in the negative direction there. To the left and down are negative directions. So here this would be an x equals ay squared kind of graph. And the a value would have to be positive because it opens to the right. And here we have a y equals ay squared kind of graph, or x squared, I should say. And a is equal to, it must be negative because it's opening downwards. Downwards is a negative direction. That's it for today's lesson. Although, I want you to try this one. It's a really good PSAT stop it, try it. I'll show you how to do it. So if you realize this kind of line, these are all k values here, it says. So these are k's. So if I plugged in there f of x equals 2, so what would f of x equals 2 look like as a graph? So that would look like here, cross about 2. It crosses that line once. It means it has one solution when x equals 2 there. But you can actually plug in different values here. So let's plug in -2. So we're going to plug that one in. So if we do -2, that would be, this is now negative. So I'm going to draw a line here. It crosses one time. There's only one solution for -2. So it does look like -3 has a good chance here. So let's try that. So f of x equals -3. Well, that would be a line that has, that goes through right there, there, and there. I don't know if you caught it, but it hit 1, 2, 3 times there. So wherever the graphs cross are the solutions. In this case, there would be 3 solutions because it's looking for 3 real solutions. So D is definitely the correct answer there. That's it for the lesson.